Welcome to another AP Statistics instructional video by Mr. Hardy. What I'm going to do in this video is go through the problem that we did in class on hiring discrimination amongst airplane pilots. Let me quickly describe the problem to you. We have 25 pilots that are newly trained, ready for jobs, 15 male, 10 female pilots. So unfortunately there were only 8 openings, job openings. So they randomly chose or used a lottery to select of the 25 pilots which ones would get those 8 jobs. After the lottery, 5 females were selected and 3 males were selected. So what happened was that some of the males were suspect that the lottery was not carried out fairly. In other words, it wasn't random. So what we want to know is could these results have happened just by chance? That's kind of what we want to know. So we want to do a simulation. We're not going to, in this particular problem, we're not going to calculate a probability. We're just on our own. What we're going to do is we're going to do a simulation and use that as our evidence. So what we do when we do a simulation is there's some things that we need to identify, and the first one is called a component. That's sort of like the primitive thing that we do over and over again. We kind of loop through it, and it just depends if we're I don't know, selecting batteries from a conveyor belt or something, and we want to check if they're good or bad. Then just selecting one battery is the component. If we're having babies and we want one male baby and one female baby, and so we want to know how many babies do we have to have, should we expect to have in order to get one of each gender. So there the component would be having babies. Here our component is drawing just one name, drawing one training pilot name from the set of all available pilots. Okay, that's it. Once we have the component, then we look at it and say, well, if we do that, what are the outcomes? So the outcomes here are going to be either male or female. I should have said female or male, the way I have it written. Okay, that's it. There's no other outcomes. Okay? Now, the next thing that we do, once we've got the outcomes identified, is we do what I call a trial description. Okay? And in the trial description, what we really want to do is how do we use how do we use random numbers to represent the situation? So here I'm going to say, and there might be a better way to word this, but I will simulate one trial by selecting 8 non-repeating numbers from 1 to 25. The way I'll do that is I will use randomly generated, or I'll randomly generate 2-digit numbers. That's important to identify, that I need 2-digit numbers in this case. And I will use the following assignments. Okay, so sometimes just it's up to you, but if you could do the assignments up here under outcomes. It doesn't matter where you do them, you just have to do them. So here we're going to assign 0, I should have put a 0 there, 0, 1 to 15 to 15 to be male pilots, and 16 to 25 to be female. I should also, to be complete, I should say that if we get a 0, 0, we ignore that, and if we get a 26 to 99, we ignore that. So we ignore those. They have no meaning for this simulation. So that's important if you can't control a calculator. You can control it and say stop at 25. Okay. I also need to say for this situation to ignore numbers between 1 and 25 that occur more than once. Okay, so if they repeat, ignore repeating. And the reason is that we don't want to select the same pilot for 2 jobs. Okay, so it makes sense in this case to do that. Not all requirement or simulations is that required. And then finally, one thing is make sure, this one's pretty obvious. I kind of say up here 8. So it's obvious when to stop, but sometimes you need to explicitly state the stopping criteria. So I've kind of been redundant here. I will stop when I get 8 unique pilots. Okay, so the next thing is the response variable. Okay, so this is what is it you're going to compute for the simulation in order to empower you to make a decision. So what I try to do is, first, after teaching this a long time, I kind of consider having a trial response variable and a simulation response variable. I break it out. In other words, what am I going to do? What am I going to count, measure, compute for each trial? So here, the response variable for a single trial is the number of females. That's what I want to count for each trial. The number of females selected out of the 8 pilots chosen. So this I call the trial response variable. Now, that's not sufficient though here. What we need to do is, once we get that, so sort of think of it like this. We get trial 1, we get 4 females. Trial 2, we get 6. Trial 3, we get 1. Okay, so let's say we did 3 trials. So here, these are our trial response variables. But now for the simulation, we calculate the proportion of times, or the proportion of trials. I get 5 or more females. So the simulation response variable is going to, in this case, would be 1 out of 3. Okay, or 33.3% of the time. Okay, so next thing we do, so this is all the documentation. Component, outcome, trial description, response variables. Those are all the instructions. Now we're actually going to do it. So it helps for the reader to have some notation. So you should just take a second and say an F's going to mean female, M's going to mean male, because it's not always obvious. And then maybe a slash is going to mean ignore. Something like that. So now I would say trial 1. Okay, so now before I begin, I just want to digress just for a second. On homework, you have the computer, and there's a way to do rand int. It tells you in the book how to do that. I will show you in class eventually. But you can generate some numbers between 1 and 25. If you're at home using a computer, here's another way. Here's a website, and you don't have to use this website. There's a bunch of them. You just do a search for random number generator. But I kind of like this one. It's called StatTrek, so stattrek.com. And if you go into this, let me just see if I can do it. I'm going to select statistics. There we go. So I get the statistics page, and I go down to Stat Tools, and right here I get random number generator. Okay, so I select that, and I'm just gonna pull it down. So you can choose how many numbers you want. I'm just gonna leave that at 100. I'm gonna go over here and say 0 to 1, and I'll come over here and say, I could go to 99, but I can save some time by just saying 25. And so I hit calculate, and it generates some numbers for me. There they are. Okay, so I can just use these numbers, copy them down, and I'm done. Okay, so again, that was called stat trek. So one way. That's where I got these numbers. Okay, so now I'm ready to actually execute my simulation. So if I remember, males was 0, 1 to 15, and this is 16 to 25. So here I have male, female, male, right? Male, female, and this would be ignore because I'm repeating it, and then 25 would be female, and 17 is a repeat, right? A repeat, so I can't count that. And then 23 is female, and then 25 is female. So let me check. 1, 2, 3, 4, 5, 6, 7, and 8. So there you go. I've selected 8 pilots. So I'm going to move on to trial 2. So it's good to indicate when you start your trials. I could start right here, make it nice and clean. Doesn't matter where you start. So this would be male, male, female, 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 male, male, and 12 is a repeat, and 1, 2, 3, 4, 5, 6, 7, male. Okay, so a couple of things you could do. If you had room over here, or if you do it, each row is a trial, you can kind of put your response variable right here. Another thing is you could kind of make a little table like this, and I've got 1, 2, 3, 4, 5, 6. So 6, and over here I have 3 if I did it right. Or another thing, I could just say RV equals 6 and RV equals 3, like that. And so now I would say T3 and keep going. So I'm not going to do that right now, but that's what you would do. So maybe you should do about 10, something like that. Okay, when you're done, I left too much room, but my response variable, let me just grab, hold on just a second. Let me do this. Let me see if I can, no, that's not going to work. Let me do this. Grab this and say edit, cut, and then I'm going to bring it, I'm just going to pull it up, edit, paste, there we go, and then back to my this. Okay, so now here what I would say is that perhaps something like my simulation statistic is one trial that has 5 or more females. So 5 or more females over, in this case, 2, and that would be like the total trials. Some documentation of how you computed what you have, especially if, I don't know, it just helps the reader track what's going on. Okay, so now we're ready to write our conclusion. So we always start with according to the simulation, and let's interpret the response variable first, or the statistic. We expect approximately 50% of the trials to select, not sure I like this wording, but select 5 or more females. Okay? So, therefore, or why don't we say first, this is a large percent therefore we do not, should be formal, therefore we do not recommend that the male pilots file a grievance. I think the I comes first. Okay? So this last part, so there's kind of two parts to this, and maybe if I thought through it I could write it just a little bit better. But the first part is interpreting the response variable. Okay? And then the second part is sort of mapping back to the question. Okay, so we want to map all the way back up. I'm just going to put a little arrow. All the way back up to this question about, is it fair? Right? Is it fair? What do we recommend to the male pilot? So make sure that you connect the results back to the question. Okay, so there you go. I hope that was helpful. Let me know if you don't have, or if you have questions, let me know. Thanks.